Good morning, students. Let us see how to implement a full adder using demultiplexer. Before getting into the topic, let us understand what is demultiplexer and then understand what is full adder so that we can easily implement a full adder using demultiplexer. So, a demultiplexer is also called demux. Okay, it is a device which is used to take a single input and forward that single input to any one of the several outputs. Is it clear? So demultiplex is a device which is used to take single input and forward that input to any one of the several outputs. That is why demultiplexer is called as one to many. It takes single input, forwarded to any one of the several outputs. That is very important. It will forward only the input to one of the several outputs. This is decided by the selection lines. To which output it needs to forward that input is decided by the select lines. The number of select lines is decided by this formula. 2 power m is equal to n. So m is number of select lines, n is number of outputs. In this case, this is a demultiplexer which has single input, one input, 1, 2, 3, 4 outputs. So number of output lines are 4. So 2 to the power of m is number of select lines is equal to 4. That is number of outputs. So 2 power m is equal to 2 to the power of 2. M is equal to 2. So number of select lines is 2. So there are 2 select lines A and B. If the select line is 0, 0, the input x will be forwarded to D0, first output. If the select lines is 0, 1, the input x will be forwarded to D1. If it is 1, 0, input x is forwarded to D2. If it is 1, 1, input x is forwarded to D3. This is a demultiplexer. The job of demultiplexer is one input, several outputs. It is used to forward the single input to any one of the several outputs depending upon the selection lines. Now what is that we are going to do is we are going to design or implement a full adder using this demultiplexer. So I need to understand what is full adder. You know, full adder is nothing but which adds 3 single bit numbers. It means the job of full adder is to add 3 single bit numbers, that is a plus b plus c. The output of full adder is sum of the 3 inputs. If by chance there is a carry generated, carry is given in the carry out. So full adder has 3 inputs and 2 outputs. Inputs are a, b, c. Outputs are sum and carry. Now, how to design this full adder using a circuit called demultiplexer is that we are going to see. So what is the first step is write the truth table of full adder. Since they have asked to implement full adder, you need to write the truth table of full adder. So how many inputs? A, B, C. So write the inputs A, B and C in, that is carry input. So what are the 2 outputs? Sum and carry. Sum and carry. You know what is, since there are 3 inputs, total 8 combinations, 0, 0, 0, 0, 0, 1, 0, 1, 0 till 1, 1, 1. Now, what is the job of a full adder? Full adder is used for adding 3 bits. So, A plus B plus C, 0 plus 0 plus 0 is sum 0, carry 0. 0 plus 0 plus 1 is sum 1, carry 1. Now see this, 0 plus 1 plus 1 is sum 0. 1 plus 1, sum 0 and carry 1. So fill the truth table with by adding A plus B plus C. Okay. After filling the truth table, we need to represent the output of full adder in min terms. Let us see how to represent output of full adder in min terms. So to represent output of full adder in min terms, first you need to see the sum. Okay, let us do it for sum. Sum is equal to, how many inputs you have? A, B, C. So sum is a function of A, B, C. How many minterms are high? Minterm is high here. So 1, 2, 3, 4. 4 minterms are high. Now go to its respective place. 1, 2, 4 and 7. So sum is high in first position 1, second position 2, fourth minterm and seventh minterm. So I have written sum is equal to 1, 2, 4 and 7. Now write it for carry. Now can you see where is the carry is high? Carry is high for 1, 2, 3, 4 places. Now go and check the combination for which carry is high. It is high for 3. Then it is high for 5. It is high for 6. It is high for 7. So 3, 5, 6 and 7. So I have written carry in terms of minterm as 3, 5, 6 and 7. Now what is that we are going to do? We are going to use a demultiplexer. What type of demultiplexer I need to use? Do I need to use 1 by 4 or 1 by 8 or 1 by 16? Depends on the inputs. Since we have 3 inputs, can you see full adder has 3 inputs? We know that 3 means 8 combinations. So it is 1 by 8 demultiplexer. Okay. So what is 1 by 8 demultiplexer? Single input, 8 outputs. So single input I and 8 outputs y0, y1, y2 till y7. What is that we are going to do is we are logically or the outputs. So I need what? Sum and carry. What is the minterms for sum? 1, 2, 4, 7 is the minterms for sum. So take 1, take 2, take 4 and take 7 or it. You get output as sum. Now what is the minterms for carry? 3, 5, 6, 7. Take 3 lead, 5 lead, 6 lead and 7 lead. You get or it, you get your carry. This is how we implement instead of using full adder. Now you need to understand. I missed one point. You need to understand demultiplexer forwards one input to any one of the output depending upon the select lines. Now select lines, how many select lines? 1 by 8 demultiplexer will have 3 select lines. What are the select lines? Your A, B and C is your select lines. Okay, so my input is 1. Depending upon the combination, if ABC is 0, 0, 0, you get sum 0 and carry as 0. This is how you design a full adder using demultiplexer. So you don't need a full adder. Now with help of demultiplexer, you get the functionality of a full adder. Okay, if they ask to design a half adder using demultiplexer, instead of full adder you need to use a half adder. Write the truth table of half adder, write the minterm representation of sum and carry and then draw the logic diagram. Clear? Thank you.